Unit 4, Day 1 notes. Today we're going to talk about classifying triangles by angles and sides. When you classify triangles by the angles, there are 4 different possible classifications, and you should be familiar with them because you talked about them in middle school. So the first first 4 terms we're going to discuss today should be familiar with you. And this is how, again, we're going to classify triangles by angles. The first possible way is acute. An acute triangle has a triangle where all angles of the triangle are acute. A right triangle is second. It's a triangle where you have one right angle. Obtuse is third. Obtuse triangles have one obtuse angle. And the last possible classification is equiangular. An equiangular triangle has all 3 congruent sides, and technically there's only one type of equiangular triangle. The key prefix to pay attention to is equa or equi, depending on who you are. That simply means same. So same angles is essentially what it's saying. So again, the 4 possible ways to classify a triangle by angles are acute, right, obtuse, and equiangular. Next, we're going to classify the triangles based on their sides and the side measures. There are 3 possible ways to classify the angles based on their sides. Again, you should be familiar with these terms as well. The first is scalene. A scalene triangle is a triangle where all 3 sides have different lengths or measures. An isosceles triangle is a triangle where at least 2 sides have the same length. So since it says at least 2 sides, that means it could be 2 or more. And the last possible is equilateral. An equilateral triangle is a triangle where all 3 sides have the same length or measure. Again, you see that prefix, equa, which stands for same, and lateral means length or distance, so same length. So again, I repeat, the 3 possible ways to classify a triangle by its sides are scalene, isosceles, and equilateral. Example 1 would like for us to classify each triangle as acute, equiangular, obtuse, or right, and explain our reasoning. So this exercise works best if you have a highlighter or colored pencils so you can trace the triangles of focus. The first triangle will be triangle ABD. So if I trace it, it's that first triangle right there on the left. If you look at every corner or vertice, they each measure 60 degrees, which is an acute measurement, so it could be classified as acute. And because each angle is the same acute measurement, it's also equiangular. Our next triangle of focus will be triangle BDC. BDC, so it's over here on the right. If I look at triangle BDC, I notice in D's corner there is an obtuse angle. And since there's an obtuse angle, the entire triangle is considered obtuse. Our last triangle of focus is triangle ABC. So if I trace it, it is the big triangle that is composed of the two smaller triangles. Corner A has a 60-degree angle. Corner C has a 30-degree angle. And then when you look at corner B, it is composed of two angles, which combined form 90 degrees. So it is a right triangle. Example 2 reads, if point K is the midpoint of FH, so point K is located right here, you know it illustrates that the distance from K to H is 2.5, so that means the distance from F to K is also 2.5. Again, we're going to classify the triangles, but this time we're going to focus on the side lengths. So we're going to use equilateral, isosceles, or scaling. Again, highlight the triangle of focus. The first one is FGH. FGH. If you look at the triangle, side FG is 5. And then GH has a tally mark just like FG, so that means it also is 5. And then FH is split into 2.5 and 2.5, which means total it is also 5. So since all three sides have the same measure, this is an equilateral triangle. Again, we're only classifying it based off of the side lengths. The next triangle we're going to look at is triangle GHL. And I knew there was a typo. It's supposed to be GJL. Sorry, guys. I couldn't quite remember where the mistake was. So again, GJL. All right. So GJ measures 8. LJ is 5. And then from G to L, it would be 5 plus 3, which is 8 in total. So it has two sides that are the same. So that means it's isosceles. Also, FGH is isosceles as well, because again, the definition of isosceles means at least two sides are the same. So again, at least means two or more, and all three of those were the same. So that's why it's both isosceles and equilateral. And last but not least, I need to focus on FHL, which is this tiny triangle down at the bottom. So side FH is 5, FL is 7, and HL is 3. So all three sides are different. So that means it's scaling. Example 3. Find the side lengths of the triangles. First things first, I got to find out what x is in order to find the side length. Notice that JK and KL both have this little tally mark. So that means JK is congruent with KL, which means that JK's measure is equal to KL's measure. Well, now that I know that, I can put 4x minus 1.3 equal to x plus 3.2, and this will help me solve for x. The first thing I would do is subtract x on both sides. When I subtract x, I'm left with 3x minus 1.3 equals 3.2. Then I would add 1.3 to both sides, which would result in 3x is equal to 4.5. Then divide both sides by 3, and you would get x is equal to 1.5. Now that I know what x is, I can figure out every side length. The first one I'll do is jk, which again is 4x minus 1.3. So that now means 4 times 1.5 minus 1.3, which would be 6 minus 1.3, which would end up being 4.7. So jk is 4.7. Now I can find KL, which is equal to x plus 3.2, which is 1.5 plus 3.2, which again is 4.7, which we said should happen in the first place because they're congruent sides. Now the last side I need to find is JL, which is 5 times x minus 0.2. So that's 5 times 1.5 minus zero point 0.2. 5 times 1.5 will give us 7.5 minus zero point 0.2 would be 7.3. Number 4 says find the side lengths of the equilateral triangle FGH. So again, equilateral means that all three sides are the same. So this side FG equals GH, which equals FH. So they're all three the same. So first you got to find out what Y is by either setting FG equal to GH or FG equal to FH or GH equal to FH. So it really doesn't matter which two you decide to use. Y should be the same answer no matter what. So you can finish that by finding Y using either one of those three equations. And then once you know what Y is, replace Y in one of the sides to figure out the measurement. So finish this example on your own. And again, make sure you take a picture. Now we're going to talk about the triangle sum theorem. If you take your a triangle and line up the three angles side by side, so watch this demonstration and tell me what you notice. All right, so angle 3. Let me rotate a little more. All right, I've lined up angle 3 and angle 2. And now I need to line up angle 1. What you should realize is all three angles of this same triangle together form a perfect straight angle. So together they would form 180 degrees or a line. This fact will be true for every single triangle out there. And this is the triangle sum theorem. The three angles of a triangle add up to 180 degrees. So that means I should be able to take angle A plus angle B plus angle C and equal 180 degrees. Now let's put this into practice. First question says find the length of the find the measure of the missing angle. So I know that x plus 53.4 plus 51.8 should equal 180. First, I'm going to combine the 53.4 and the 51.8, which would give me 2, 5, and 10. So 105.2. Bring down my equals 180. Now I need to subtract 105.2 from both sides. To find my missing angle. And you would have x is equal to 0.8. That would be 9, so 4. Mm, 8. No, that sounds way too large. 74. Sorry. 74.8. 74.8. Yes, would be the missing angle. All right, this one would like for us to find the measures of angle B and angle C. But to do that, I first need to find x. Again, all three angles, angle A plus angle B plus angle C should equal 180. So that means 54 plus 5x plus 17 plus 6x minus 1 should equal 180. So let's combine all of our like terms first. I'll do the x's first. So I have 5x and 6x, would make 11x. 54 plus 17 is 71. Minus 1 is 70. So positive 70. Bring down my 180. Now subtract 70 from both sides. You would have 11x equals 110. And divide both sides by 11. So x is equal to 10. Now that I know what x is, I can find the measure of angle B and angle C. The measure of angle B is equal to 5 times x plus 17. So 5 times 10 plus 17 would be 50 plus 17, or 67 degrees. And lastly, the measure of angle C is equal to 6 times x minus 1. So that's 6 times 10 minus 1, or 60 minus 1, which is 59 degrees. And this concludes your notes for today's lesson.